Now where we have r over negative 3 is greater than 0.9 leads us to a rule that we really haven't touched upon in this lesson. So it's important that it is introduced at this point because you definitely don't want to be introduced to it for the first time when we're looking at the homework here. We know what to do here. We know that variable on the left, r is fine, numbers on the right, 0.9 is fine. What's not okay here is the negative 3. That's what's going to have to move here. Right now I'm dividing by negative 3, so I'm going to do the opposite, which is to multiply both sides by negative 3. So I've got r, and I've got 0.9 times negative 3, which is negative 2.7. Now what I'm hesitating to do here is to fill in the sign, because the rule that you need to know here is that when you multiply or divide by a negative, it flips the direction of the inequality sign. So that inequality sign isn't going to point to the right anymore. Or in other words, it's not going to be greater than. It's actually going to change into less than. I am preserving the inequality as is because what it really said when I had r over negative 3 is that I was dividing by a negative, or that there was a negative into that variable. Well, I don't want a negative value of the variable. I want a positive value of the variable. So by flipping the inequality sign around, I actually fix that problem. I'm going to attach a video to this presentation online so you can see a full explanation of why flipping that around does actually preserve the question, so you can see why that works in more detail. So when r divided by negative 3 is greater than 0.9, the solution works out to be r being any value less than negative 2.7. Here's 6b is greater than or equal to 25. So variable on the left, b is good. 25 on the right, being a number, is good. 6 not so good, so we're going to fix that by dividing out 6 on both sides. And when I do that, I end up with b is greater than or equal to, well, 25 over 6, that's going to be something a little bit bigger than 4, because we know 24 divided by 6 would give me 4. 25 divided by 6 generates 4.16 repeating. So b is some value bigger than 4.16 repeating. Finally, it cost the class $15 to make cookies for the bake sale. How many cookies must they sell at 10 cents each to make a profit? So if we just sold one cookie, that would be 10 cents times 1. 2 cookies would be 10 cents times 2. 3 cookies would be 10 cents times 3. If we don't know how many cookies, that's going to be 10 cents times x. The mistake people are likely to make here, or I'm going to use c for my variable. The mistake people are likely to make here is they would just write 10. We don't want to mean 10, because if I just write 10, that would be like $10. But we're selling these at 10 cents. Okay, they've got to eclipse the $15 mark in order to make a profit. So it's got to be bigger than 15. If we hit exactly 15, then I'm not making a profit, I'm just breaking even. And the question's asking me to make a profit, which is why I'm writing greater than. All right, multiplication equation, so I'm going to solve now by dividing out 0.10. We know that's what's got to move, because we're going to say variable on the left, number on the right. So the 0.10 is the thing that's wrong here. And so those cancel each other out and leave me c. And I've got 15 is greater than 0.10, which is 150. So I'm going to have to sell 150 cookies in order to make a profit.